Ever wondered how AI could turn a single photo into a lifelike talking video? Or create realistic animations from just audio? Let's dive into the cutting-edge science behind these amazing technologies. At the heart of this revolution are systems that learn to generate videos by understanding the relationship between sound, facial expressions, and motion. Imagine a virtual character that can smoothly shift from smiling to frowning, like a real person, while keeping their voice and mouth movements perfectly in sync. How does that work? It starts with something called expression manipulation. Here's the trick. The system uses two reference clips, say a happy face and a sad face. It then blends their emotional blueprints, which are like digital fingerprints of how the face moves. By adjusting a simple slider, called the alpha value, you can create a seamless transition between these expressions. It's like mixing paint colors, but for emotions. This shows the system can capture and translate feelings into realistic facial movements. But faces aren't just about expressions, they also move. Think about head nods, eye blinks, or a quick glance to the side. Our system uses a diffusion model to generate these natural, diverse motions. Even with the same input, you'll see different yet believable movements, like a character looking left then right, or blinking at just the right moment. And here's the magic. The expression and mouth shape stay consistent. It's like giving your virtual character a personality with realistic body language. Now, what if we could make this even more dynamic? Enter semantically aware expressions. Imagine feeding a cheerful message or a sad one into a text-to-speech system. The audio from these texts guides the model to generate talking faces that match the emotions. In one example, the left side shows a happy face, the right a sad one. Even cooler, the system can infer expressions directly from audio, no text needed. Picture a virtual assistant that sounds excited or worried, just by the tone of its voice. But how do we control all these elements separately? Our system lets you tweak individual facial components. Want to focus on mouth movements, head poses, or emotions? You can mix and match, like combining lip movements with head gestures or adding eye blinks. It's like having a puppeteer for every part of the face. Each base in our system represents a specific motion, like opening your mouth or rotating your head. By adjusting these, we can precisely control the final output. But how do we know this works? We tested it. When we removed key parts of the system, the results got worse. Faces looked blurry or emotions were off. And when we tried different numbers of bases, we found 20 for mouth movements and 10 for expressions gave the best results. It's all about balance. Now let's talk about the breakthrough that's changing the game, EDTalk++. Traditional AI methods for creating talking faces often feel like trying to cook a gourmet meal with a single spice. They might produce decent results, but they lack control. For example, if you want a character to smile and tilt their head, the AI might mess up the timing or make the expression feel fake. That's where EDTalk++ steps in, like giving the AI a full kitchen with every tool it needs. So how does it crack the code? The secret sauce is something called disentanglement, a fancy way of saying separating the parts so they don't mess with each other. Imagine your face as a team of actors. One handles the mouth, another the eyes, a third the head pose, and a fourth the emotion. EDTalk++ gives each actor their own spotlight, so they can perform independently. This means you can tweak a smile without messing up the eyes, or adjust a head tilt without changing the emotion. Here's where it gets cool. EDTalk++ uses modules like tiny AI chefs, each specialized for a task. One module deciphers mouth movements from speech, another reads eye blinks, and a third. It's the emotion expert, figuring out if someone's happy, surprised, or sad. These modules work together but stay out of each other's way, thanks to something called orthogonal bases. Think of them as non-overlapping tools in a toolbox. No more wrench-a-screw disasters. But here's the kicker. EDTalk++ doesn't need extra data like 3D models or pre-recorded poses. It's smart enough to learn from just a single image and audio. Traditional methods, they'd need mountains of data to get the same results. EDTalk++ also adapts to both audio and video inputs seamlessly. Want to animate a face from a voice clip? Done. Need to match a video's expressions? It's got your back. And the results? Let's talk numbers. EDTalk++ outperforms other models in key metrics like PSNR, image clarity, and SSIM, visual similarity to real faces. It's also a speed demon, training in just 1 hour on a regular GPU, while others take weeks on supercomputers. But the real wins. User studies show people find EDTalk++'s expressions the most realistic, with smoother lip sync and natural emotions. So what's the big deal? EDTalk++ isn't just about making faces move, it's about giving them life. From virtual assistants to immersive VR, this tech is paving the way for digital characters that feel human. Next time you see a lifelike talking head, remember, it's not magic. It's the result of decades of research, clever engineering, and a little bit of AI alchemy. Thanks for watching, stay curious, and keep exploring the future of artificial intelligence.